Top 10 Mind-Blowing Facts About Our World, Ultimate Extended Edition. Our planet is a source of constant wonder, a place where the familiar and the astonishing intertwine. We'll embark on an in-depth exploration of 10 incredible facts about our world, enriching each with historical context, scientific explanations, and related trivia to fully appreciate their significance. 1. Earth isn't perfectly round, the oblate spheroid, and its implications. As we've established, Earth is an oblate spheroid, bulging at the equator and flattened at the poles due to centrifugal force. But how was this discovered? Historical context. Ancient Greek scholars like Eratosthenes had already deduced that Earth was spherical in the 3rd century BC. Later, Isaac Newton, in the 17th century, provided the theoretical explanation for the oblate shape based on his laws of motion and gravity. The equatorial bulge. The equatorial diameter is approximately 43 kilometers, 27 miles, larger than the polar diameter. This bulge has implications for satellite orbits and navigation systems, which must account for the Earth's non-spherical shape. Related fact: the Earth's rotation also causes a slight equatorial bulge in the ocean, meaning sea level is slightly higher at the equator than at the poles. 2. The driest place on Earth is in a desert next to an ocean, unpacking the Atacama's aridity. The Atacama Desert's extreme dryness is a result of several converging factors. Rain shadow effect, the Andes Mountains to the east block moist Pacific air from reaching the Atacama. As the air rises over the mountains, it cools, condenses, and releases its moisture as rain on the eastern slopes, leaving the Atacama in a rain shadow. Cold ocean current. The cold Humboldt Current flows northward along the Chilean coast, cooling the air above it and inhibiting evaporation, further reducing rainfall. Subsiding air. High-pressure systems in the atmosphere cause air to descend over the Atacama, further suppressing cloud formation and rainfall. Related fact: some parts of the Atacama are so barren that they are used as Mars analog environments for testing rovers and other equipment for potential missions to the Red Planet. 3. Days are getting longer, a cosmic slow dance. The gradual lengthening of Earth's day is a consequence of the tidal interactions between Earth and the Moon. Tidal breaking. The Moon's gravity creates tides in Earth's oceans, and the friction of these tides against the ocean floor slows down Earth's rotation. Angular momentum transfer. This slowing of Earth's rotation transfers angular momentum to the Moon, causing it to slowly spiral outwards. Historical evidence. Scientists can measure the lengthening of the day by studying ancient records of solar eclipses and analyzing growth rings in fossil corals, which reveal the number of days in a year in the distant past. Related fact: billions of years ago, a day on Earth was only a few hours long. 4. There's a place where gravity isn't the same. Exploring gravity. Anomalies. Variations in Earth's gravitational pull, known as gravity anomalies, provide valuable insights into our planet's interior. Mass distribution. Areas with higher density rocks or large underground masses will have a slightly stronger gravitational pull, while areas with lower density or voids will have a weaker pull. Geological studies. Scientists use sensitive instruments called gravimeters to measure these variations, which help them map underground geological structures, locate mineral deposits, and study tectonic plate movements. Related fact: one notable gravity anomaly is found in the Hudson Bay region of Canada, believed to be related to the melting of a massive ice sheet at the end of the last ice age. 5. The deepest part of the ocean is deeper than Mount Everest is tall, venturing into the abyss. The Mariana Trench's extreme depth is a testament to the powerful forces of plate tectonics. Subduction zone. The trench is located at a subduction zone where the Pacific Plate is being forced beneath the Philippine Plate. This process creates a deep depression in the ocean floor. Extreme pressure. The pressure at the bottom of the Mariana Trench is over 1,000 times greater than the pressure at sea level. Unique life. Despite the extreme conditions, specialized organisms have adapted to thrive in the Mariana Trench, including unique species of fish, crustaceans, and microbes. Related fact: only a handful of people have ever reached the bottom of the Mariana Trench, including film director James Cameron in 2012. 6. Earth has a magnetic field that protects us, a shield against the sun's fury. Earth's magnetic field is generated by a complex process within its core. Geodynamo. The movement of molten iron in Earth's outer core creates electric currents, which in turn generate the magnetic field. Magnetosphere. The magnetic field forms a protective region around Earth called the magnetosphere, which deflects most of the charged particles from the solar wind. Auroras. Some charged particles do manage to enter the magnetosphere, and when they interact with the Earth's atmosphere near the poles, they create the beautiful displays of light known as auroras, northern and southern lights. Related fact: Earth's magnetic field is not static. It can change in strength and direction over time, and even flip its polarity. North becomes south and vice versa, although the timing of these flips is unpredictable. 7. There's a third pole on Earth, the Tibetan Plateau and its importance. The Tibetan Plateau's high altitude and vast ice reserves make it a critical part of the global climate system. Water tower of Asia. The plateau's glaciers and snowpack feed many of Asia's major rivers, including the Indus, Ganges, Brahmaputra, and Mekong, providing water for over 1 billion people. Climate regulation. The plateau's high altitude and large ice cover influence regional and global weather patterns. Environmental concerns. Climate change is causing rapid melting of glaciers on the Tibetan Plateau, threatening water resources and increasing the risk of glacial lake outburst floods. Related fact: the Tibetan Plateau is also a biodiversity hotspot, home to unique species of plants and animals adapted to the harsh, high-altitude environment. 8. The world's largest living structure is a coral reef, the Great Barrier Reef's plight. The Great Barrier Reef's vastness and biodiversity make it a natural wonder of the world. Coral polyps. The reef is built by billions of tiny coral polyps, which secrete calcium carbonate to form their hard skeletons. Ecosystem services. The reef provides habitat for a vast array of marine life, supports commercial fisheries and tourism, and protects coastlines from erosion. Threats. The Great Barrier Reef is facing severe threats from climate change, ocean warming and acidification, pollution, overfishing, and outbreaks of crown-of-thorns starfish. Related fact: the Great Barrier Reef is so large that it can be seen from space. 9. We produce enough food to feed everyone, but it's not distributed equally. The global food security challenge. The issue of global hunger is not primarily a problem of food production, but rather one of access and distribution. Food waste. A significant amount of food is wasted at various stages of the supply chain, from production and processing to retail and consumption. Poverty and inequality. Poverty and economic inequality limit people's access to food, even when it is available. Conflict and instability. Conflict and political instability can disrupt food production and distribution, leading to food shortages and one famine. Related fact: sustainable agriculture practices, reducing food waste, and improving food distribution systems are crucial for achieving global food security. 10. There are more possible iterations of a game of chess than there are atoms in the observable universe. The power of combinatorics. The sheer number of possible chess games highlights the power of combinatorics. Shannon number. Mathematician Claude Shannon estimated the game tree complexity of chess, the number of possible games, to be around 10 to the power of 43. Atoms in the universe. The estimated number of atoms in the observable universe is around 10 to the power of 8010 to the 80th power. Implications. This comparison illustrates the vastness of mathematical possibilities and the complexity that can arise from even relatively simple rules. Related fact: while computers can now beat the best human chess players, they still don't solve chess by analyzing every possible game. Instead, They use sophisticated algorithms and heuristics to evaluate positions and make decisions. By exploring these facts in such detail, we gain a deeper appreciation for the wonders and complexities of our planet. It underscores the importance of continued scientific exploration and our responsibility to protect this unique and precious place we call home.